Hello and welcome to Mr. Barkland's Chemistry Lab. This week we are doing a distillation of fruit soda. What the purpose of that is to do is to split up the soda into its component parts. Namely, the four parts are something called a fruity ester, which is where you get some of the flavoring and smell. That's the first part. Number two, the carbon dioxide that's dissolved in the soda. Number three, the water that is the bulk of what you were drinking. And then number four, the sugar or the syrup that gives some of the caloric content, the sweetness to the soda. So first things first, you're going to open up your soda. You are not going to take a drink. We did not do that in chemistry class. And you want to measure out your soda. It's probably a good idea to use a funnel. I do not want spilled sugary stuff in my lab. You are doing 100 milliliters of soda. Let's see. One of the problems with this, you do not want to measure the level of bubbles. You just want the level of liquid. While one person's working on this, you could have somebody else make your distillation setup here. Here is, okay, it's going to take me a bit. Okay, oh, I was actually perfect. It's right at 100. So we've got our liquid that we are going to distill. You should be grabbing ice bath. You want plenty of water in here so that you can put your collection apparatus into the water. Okay, before you add your liquid, it's a good idea to add some boiling chips. I'm going to tilt this a bit here. Boiling chips, I just smashed a coffee mug because I could not find my old boiling chips. They're just little bits of ceramic. You put them in there. The idea is they create more surface area for bubbles to form when you're boiling something or heating something up. Sometimes when you're heating, you might have a tendency for a really big bubble to form, and it will kind of, big bubble will form, and it'll go up to the top and kind of splash. You might have had this happen to you before when you're cooking, especially with like marinara sauce. The boiling chips help to get smaller bubbles so you don't have that, that's called bumping, where you have a different unevenly heated parts of the water that give you big bubbles. So got a couple boiling chips in there, super important. Rinse this out. Okay, and then we're going to put our soda in there. Okay, there we go. And you'll want to assemble your apparatus here now. Once you've reached this step, make sure to call me over so I can kind of give you the go-ahead to make sure you are good to go. We've got some glass tubing inside of here. We've got the thermometer inside of here. We want to be measuring the temperature of the liquid, which, okay, I'm not sure why that's, I think we're going to add more than 100 maybe. We'll see. I think we might do more than 100 milliliters. We used smaller flasks last time. So at this point, you can go ahead and get this heated up. Get that out of the way. Get your Bunsen burner going. A little sensitive. There we go. Okay. Now you probably can't see the Bunsen burner super well in terms of the flame. I've got maybe like an 1.5 inch flame here. That's pretty good. Like I said, you might be able to see a little bit against. Oh, there you go. You can maybe see that now. This is probably a pretty good level for putting beneath here. I might actually get a little bit more flame or lower my reaction down a little bit. Probably the biggest safety concern, aside from just hot metal and that kind of stuff, is the idea that you don't want to ever touch this plastic to the mesh on the side here. You could easily melt that. Okay, so first thing I'm smelling for is that fruity ester. So remember, you never stick it up your nose. You put it right here and you waft. So have one person be your wafter, and as your soda is heating up, you are trying to smell the fruity ester, which is the molecule that gives kind of some of the flavoring and the smell. It's that really fake strawberry smell that you might be aware of. And okay, just right. I think right now. No, I have not smelled it yet. Okay, so it's still heating up there. What you want to do is you want to have somebody monitoring the temperature of your reaction so that you can tell for sure what the temperature is when the fruity ester is boiling. The idea is that ester has a pretty low boiling point overall. So notice I'm constantly wafting. I'm going to turn the gas up a bit here so I go a little bit faster. Oops, oh God, I turned it off. Okay, you can be a little more patient because we've got a full block period. Okay, now we're supercharging that now. Holy cow. No smelling it, I don't smell it yet. And right now, okay, I can definitely smell that really strong strawberry smell. You might have grape or orange, depending on your soda. And so I would take a look at this and figure out what the temperature of my soda was right now. I'm not going to tell you because it's part of the lab. Right at this moment, you really quickly want to get this put into your bromothymol blue. Be careful about reaching around Bunsen burners like that. We're going to talk about bromothymol blue probably Wednesday during our short McMean day. What bromothymol blue basically does is it changes color when you have carbon dioxide present. That's because carbon dioxide actually makes an acid. It's called carbonic acid in water when you dissolve it in water. And bromothymol blue turns into kind of a greenish color. Right now it's hopefully very obviously blue. And as we continue to heat this, you should hopefully start to notice some bubbles. Oh, so I was doing something wrong. I did not have it fully submerged in there. Make sure you're seeing actual bubbles in there. And if you're watching this, hopefully you're noticing a color change. It's no longer blue, it's now green. Let me hold this up to the camera. You can see kind of a clearish green color. So at this point, really quickly, you want to stick the collection apparatus on there. Because at that point, all of a sudden, you're going to get water vapor coming out of here. Notice I've got my that big test tube. That's my collection apparatus inside of my ice bath. This is going way too hot. Like I said, you're going to want this a lot lower, maybe more down there. You really want to monitor the outlet on here. It's really hot. I should just burn myself. You want to watch the outlet, this tube right here. You never want water vapor to be coming out here. Your goal is that whenever the water vapor enters here, it hits the really cold ice and then condenses, there's a vocab word, into liquid water. Let me show you what we got so far. So you'll notice we've got a little bit of liquid water down in here. Notice how right now you can see all that steam coming out here. You don't want that to happen. You're losing that vapor right now, and this can also be kind of painful and hurt. So make sure that's submerged. Notice that stopped, and now it started again. You want to make sure you've got enough ice in there at a high enough level that you are always condensing all of that vapor into liquid water. So like I said, I kind of went through that really fast. It's going to be a lot easier if you have a lower temperature because you're going to measure it a little bit more slowly. So you're going to want to measure what temperature the ester boiled at, what temperature the carbon dioxide started boiling off at, and then also you want to collect as much of that liquid water as possible. So like I said, we're going to be doing maybe a little bit more than 100 milliliters of soda. I think we did 200 milliliters last year. As this test tube fills up with more and more water, you can actually empty this out into another collection apparatus. Hello there, we're just recording a video here. And that is about it. I will see you on Thursday or Friday. Have a good one.